Thank you for the offer. Given that this is your differential equation, that's for this slope field right here, verify your guess analytically. So doing it analytically, we're going to use Euler's method. So let's write this out. This is your first time, guys. You ready? Right, dy over dx equals y. Now this is your first goal. Your first goal is to separate the variables. You want all the y's on one side and all the x's on the other side, including the dx and the dy. Okay, so if we could like think about this algebraically and think about like we're multiplying both sides by dx. So now we have dy over dy equals dy times dx. Now how would I get that y over to the other side? You divide it, so we would get 1 over y dy equals dx. Is everybody cool? Now, the dx doesn't have an x next to him, so if you want to, you could put a 1 next to him if it makes you feel better. The next thing I'm going to do is I'm going to integrate. So I'm going to integrate both sides. Ooh, things just got kind of familiar, but maybe weird. All right, so do you guys know what the integral of 1 over y is? Natural log of y, absolute value, plus c. Now, you have to say c sub 1 because we're going to have multiple c's here. We're going to have lots of different constants, and we have to differentiate between each constant. The y has to be an absolute value because here it doesn't matter if the y is negative, okay, but here it does matter that the y is negative. So we have to make sure that we're saying, hey, this is going to be positive, all right? And in all honesty, when it comes to solving stuff, it doesn't change your answer if you have absolute values or not. We're just being official when we put the absolute values there. Now, on the other side, we have a 1. What's the antiderivative of 1 with respect to x? Because this is the dx side. With respect to x, what would we get? Yeah, we would get x. And then you would get plus c sub 2. So we have a different constant, and I'm doing this, I'm being extra here because I want to make sure you guys understand the differences with the constants, okay? So now, I can move this constant over to the other side, and those constants would combine, right? And they would create a new constant. What is it? We're going to say c sub 3. So we have that natural log of the absolute value of y equals x plus c sub 3. So this constant, and this constant, whatever they might be, are all different numbers. Next, let's get the y alone. How would you get that y out of there? We're trying to find a general solution here, people. So we got to get the y alone. That's how we solve a differential equation. So what I do? Yeah, raise everything to a power or to the base of e. Okay, so this would cancel out with that, and so I'd be left with y. And then on the other side, we can just keep the absolute values if we want. On the other side, we have e raised to the x plus c3. Ooh, interesting. Now, because we have the absolute values, technically, this can be a positive e raised to the raised to the x plus c3, or y equals negative e raised to the x plus c3, right? It could equal either of those. So here's our slope field. Let's put it in. You guys ready? How would this look? Let's see. We would go e, I need my e raised to the x, and I need to put parentheses so it stays up there, plus, let's just use a c, yeah? Add a slider there. Okay. There you go. Does our solution fit our slope field? Yes. Is this thing obeying all the baby tangent lines? Yes. What if there was a negative in front of this e? Do you think it would still be obeying it? Oh, it still obeys it. Check that out. So it's still obeying it. It's just going downwards. So we found the two general solutions. You guys see that? Well, I shouldn't say too general because the graph is actually graphing a particular solution. What is C right now? It's 1. And I don't know what is the particular solution yet, because you see, if I let C change, it'll just give me a bunch of other functions that fit this graph. So we have to find the particular solution by plugging in a point to this function. So the way you would do that is you would need an x and a y. So here, let's write it like this. So if they gave you an initial value, you'd be able to plug those in to the x and the y to find the value of c, and then you would find the particular solution. Right now it's general, so all these solutions are solutions of this differential equation.